Hello, in this video, I will explain to you how to find I1, I2, and I3 using mesh current analysis. So I will need to find out I1, and then I2, and I3, and we will use mesh current analysis, mesh current method, mesh current method. Okay, and the first step that we need to do is one, identify and label all the loops. Identify and label all the loops. Okay, let's see what loops that we have in this circuit here. Okay, we have this one here, the first one, and let's name this loop here as IA. And then let's name another loops here. We have IB. Good, so we have only two loops in this circuit, IA and IB. And then the second step that we need to do is we need to do KVL, the Kirchhoff voltage law for each loops. Okay, how to do that? Let's do that. The first one will be KVL at loop IA. KVL at loop IA. What is KVL? KVL said that the sum of the voltage in a loop will equal to 0. Good. Okay, let's see here. IA will pass through this 100 volt voltage source. So we know that the magnitude is 100, but then we have to be very careful about the sign. It entered from the negative terminal here. So we will have negative sign, and then the value will be 100 volt. Good. And now let's move on to this 4 ohm resistor. So I will have plus 4. But then remember that we need voltage. 4 here is a resistance. So we need to multiply it by the current. However, we need to multiply it by the loop current, not this one, right? We only see the loop current. So we will have IA here. Okay, now let's move on to this 10 ohm resistor here. So we'll have plus 10. Again, we see only the current loop. So we will have IA here. And we are working on IA, so IA came first. But then here, IB goes to the opposite direction. If you see here, IA is going down, but then IB is going up. So I will have to subtract it with IB. So I will have it like this, and all of that will equal to 0. Good. And let's do simplification. So I will have minus 100 and then plus 4IA, and I will distribute this 10. So I will have 10 IA minus 10 IB, and that will equal to 0. Good. 4 plus 10, that will be 14. We'll have 14 IA, and then minus, I think I will have 10 IB. Okay, let's move this minus 100 to the right hand side. So I will have 100. And I think nothing further that we can do from here. Let's save this as equation number 1. Good. Now let's do another KVL. Okay. We'll have to do another KVL, but this time at loop IB. Okay, KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's start from that 10 ohm resistor. 10 ohm. But then currently we are working on IB here. So we multiply it by IB first. But if you see here, IB is going up, but then I1 is going down, which is the opposite direction of IB. So I subtract IA from this. Good. And then now we have this 5 ohm resistor. So I will have plus 5 multiplied by the only current that passed through it, but only loop current. So we will have IB there. Okay, now we will pass through this voltage source, but the current goes from the positive terminal. So I will have positive sign. Then the magnitude will be 40. So I'll have 40 here. And all of that will equal to 0. Okay, now what else? Let's distribute this. So I will have 10 IB minus 10 IA. And then plus 5 IB. Okay. And then let's move it to the right hand side. So I will have minus 40 here. Good. And here I will have minus 10 IA plus 25. No, not 25. Minus 10 IA plus 15. Yeah, 15 IB. And that will equal to minus 40. Good. And I think that is the second equation here. So we have two equations and two variables. Okay, maybe let's save the equation and we move on to the next step. Okay, now let's do the third step here, which is solve the resulting equation. So I think I just use substitution here. So we will need to multiply this by 3. And then I need to multiply this by 1. Why? That will become 30, and this also, no, that will be multiplied by 2. So the coefficient of IB will be minus 30 and 30, so that will cancel each other, right? So we will have 14 multiplied by 3, that will be 42 IA, right? And then minus 30 IB, and that will equal to 300. Good. And then now we will have minus 20 IA, and then plus 30 IB, and that will equal to minus 80. We can just add them up so that minus 30 IB and 30 IB will cancel each other. So we will have 22 IA, and then that will equal to 220. And we will get our IA. IA is 220 divided by 22, that will be 10. And the unit here will be in ampere because all of that is in SI unit. Okay, so we know that the value of IA is 10 ampere. Okay, but then we still need to find out what IB is. We can just plug this into one of the equation. So let's plug it into equation number 2. So we will have minus 10. And what is IA? IA is 10. And then plus 15 IB. And that will equal to minus 40. This will becomes minus 100. And then plus 15 IB. And that will equal to minus 40. We can add both sides by 100. So I will have 15 IB here. And then this one will be 60. Right, 60. And so we will have our IB here is equal to 4 ampere. Okay. So we get the loop currents here. IA is 10 ampere and then IB is 4 ampere. But we still need to solve one more step. let's save what is IA and what is IB, which is get us to the last step, which is answer the question, right? Answer the question. So the question is asking us for I1, I2, and I3. So let's do exactly that. What is I1 here? I1 is the only current that pass through this 4 ohm resistor. And for the loops here, the only current that pass through it is IA. So we know that I1 is equal to IA. So I1 here is equal to this one. So I will have 10 ampere. Here is one of the answer that is asked by the question. And then what else? I need to find out I2. Again, I2 is the only current that pass through this 5 ohm resistor, and that is this loop current there. So I will have IB here. So I will have I2 is equal to IB, which is 4 ampere. Okay, nice number there. And then what is I3? I3 there is the current that goes down here that pass through this 10 ohm resistor. But then there is two currents that pass through this 10 ohm, and which is going down or the same direction as I3 is IA, and the one that has the opposite direction of I3 is IB, so I put minus sign there. So I will have I3 is equal to IA minus AB, which is 10 minus 4. So we will have I3 here is equal to 6 ampere. And this is the final value that we are looking for. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.